All right, so here we're moving on to chapter 7.3, Gaussian Elimination, off after the famous mathematician something Gauss. I should probably know his first name. Anyway, solving systems of three linear equations. So the idea here is that we're going to have, we're basically going to be moving into three dimensions. Okay, so we're going to recall that if we've been learning about systems that only have two variables, and the whole idea of that is that in reality that means that it's in two dimensions. The way we generally look at it is x and y. What we're going to do in a moment is we're going to extend that out into the third dimension, the dimension we live in, z, and we generally refer to that as z, right? And when we did this, what we were basically looking at before is, since it was in two dimensions, we represented that generally with lines. We also worked with parabolas and all of that, but the solutions lie at their intersection. That's not going to change. The intersection is still going to be what we're looking for. But what we're going to find is that when we're in three dimensions, we had to find it a little bit differently. Okay? Woo. And again, that's that idea of the third dimension there. So possible solutions to a three-variable system. And if this doesn't make perfect sense, don't worry about it too much. But basically, we're going to look through all the different possibilities. Instead of looking at them with lines, we're going to take a look at them with planes in this case. Okay. So one solution, order triple, and again, we're going to have an x, a y, and a z. Okay. And again, that's x, y, and then the third dimension, z, where it'd be kind of popping out of the paper there. Okay. Now, the idea here is that we're going to run into, or this is one example where we'd have three sheets of paper, and basically they would intersect, and they would end up only intersecting at one actual point where all three of them went in there. In three dimensions, it's tough to show on a two-dimensional space like a screen, but hopefully you can kind of see what's going on there in that we'd only have one place where all three of the planes exist at the same time. Now we could also have no solutions where the planes are all parallel to each other. We could also have a scenario like the one down here, almost like a triangle, where we only have two planes intersecting at a time. So this would be a solution for two of the equations in the system, but not all three. And again, we get two of them here and two of them on that line as well. Okay, or another scenario where again we have two of them here and two of them here, but there's no scenario where all three sheets of paper are intersecting at the same time. Or there could be an infinite number. Okay, and that would be when you have basically all three of them, they intersect at a line, because obviously this line here is going to extend out, or these planes extend out infinitely. So this line where they intersect will actually extend out infinitely as well. So those are all the different ways we could look at it. Now, when we look at an example like this, what we're going to see is this is going to be kind of like the scenario we want. Because if you notice, this one has three variables, this one only has two, and this one only has one, and so we already know what z equals. So if we want to know what y equals, hopefully you're thinking the big S word, we can just use substitution. Okay, we're going to put this in what's called row echelon form, and that's a fancy way for saying that we're going to number the equations. Okay, and it's important that you do this each time because these are going to get really messy, and if you don't number them, it's going to be really challenging. So in this case, since it's already in this form here, it's fairly simple. We can go ahead and just say, well, if z is equal to 3, then I can replace the z right there with 3. Okay, and then we would find that y is equal to 5. Well, once we know that y is equal to 5, well, then this equation up here is a lot less daunting because we can actually just substitute in z and y, and we would only have x remaining as an unknown. We can solve, and we find that x is equal to -1. Now, when we write these out, we're going to write them out as an ordered triple. You're used to seeing an ordered pair. That's because we're used to being in two dimensions. We're moving to three dimensions now, so we need an x value, a y value, and a z value. Okay? And that is how I'm going to want your answers. Okay? There's a couple names for this. One would be triangular form, or triangular system, or row echelon form. And again, it's just kind of, like I said, a fancy way for saying that we have it in a form that allows us to find all of this. And you notice it kind of makes a right triangle there. Now, we want to be able to do this even when we're not given as much, basically as easy of a problem as what we're given there. So the way we're going to go ahead and do that is through Gaussian elimination. So first you put it in we want to put it in row echelon form. That's our whole goal. So we're trying to get that nice triangle, right? To where we have three variables in this equation right here. We have one or two here and one down here. Okay, and you can move these around. It's not like they have to stay in the order they're in. Now, the way we're going to do that is first we're going to get rid of one variable, and that'll give us the second part of our triangle here. Okay, should be like this. Okay, terrible triangle. Okay, but you get the idea. Is that we're going to get rid of one variable, and that'll give us this piece right here. And then if we get rid of a second variable, well, then we're going to be good with that one as well. And you can choose whichever variable you want to use. All right. So we go ahead and we number out our rows, and then we want to make the coefficient of x equal to 1 in row 1. This part, to be honest, isn't the most important part. You can get away with not doing it, but it's always nice to have a 1 as a coefficient. So all we did here was we swapped rows 1 and 2. Okay, and now I'm going to renumber them. This way I just stay organized as I go. Now we're going to use row 1 to eliminate the x's with row 2 and 3. And now we're going to see why it's nice to have a 1 as a coefficient. Because if you have a 1 as a coefficient, if I want to eliminate this, what's really easy to tell, all I have to do is multiply it by -2. If I multiply that by -2, I get this equation. Now I almost want you to basically forget about this one, because this is row 2 right here. And what we're basically doing is we're adding this to row 2. Now, what we're adding here, you shouldn't even think of it as part of the system. Just think of it as we're adding something, and we can add anything we want as long as the two sides are equal, okay, so that we can eliminate variables. And that's going to give us a new row 2. Okay? Now we're going to do the same thing here. It's going to replace row 2. Now we're going to do the same thing with row 3. And again, we have that coefficient of 1 up here, so it makes it really easy. All I have to do is multiply this by -3. If I do that, I get this new equation. Again, we're now forgetting about this. It's just a tool. We're never actually touching row 1. We're just using row 1. And so the next piece of the puzzle here is that we're going to go through and add those up. It gets rid of the x for us, and this will now replace row 3. And as you can see, what we're really doing here is we're trying to get down. Now I have my 3 variables here. I only have 2 in row 2 now. So all I need to do is now eliminate one of the variables from row 3, and I'm good to go. And of course, in this case, we're going to try to eliminate z. So moving along, if I want to eliminate that last one, I renumber them. Now I'm going to multiply the coefficient of y in row 2 so that it will equal 1. And we're going to see why in a second here. Okay. So multiply 3 by -1/2, and then I'm going to swap it with row 2. So you'll see what I'm talking about here in a sec. So I take the third row here. I'm going to multiply it by -1/2. And now I'm going to basically flip these rows. So that might seem a little bit confusing, but really all I did was I flipped these rows, and then I multiplied both sides of this equation right here by -1/2. And I did that so that, again, I would have that nice 1 coefficient in front of the variable I'm trying to get rid of. If you don't want to do it that way, it's really just a trick to make the computation easier. Okay, I renumber them. Now I'm going to use row 2 to eliminate row 1. So I have my row 2 here. If I want to eliminate row 1, I need to multiply by 3. Again, you're going to basically forget about this. We're just using it as a tool. When I add these up now, I'm left with 5z is equal to 15. Okay. Z equals 3 is going to replace row 3. Now I have my Gaussian distribution, and now I can simply substitute back in and solve for the rows. So I substitute this z in to the second row here, and that's going to allow me to solve for y. Then I substitute both of the value y equals 2 and z equals 3 into the first equation here. and that allows me to find x equals 1, and we always write our answer down, final answer down, as an ordered triple. And that's it. That's the basic process. Please come in with any questions so we can discuss in class.